or maybe it's like a fashion statement where you know how clothes will be like very sparkly and reflective, but you can turn that on and off. So either some like material structure, or maybe you run a current through it and it causes molecules to align in such a way that they become very reflective. Good morning, y'all. I'm your MC, Jonathan, and welcome to the Pample Pod.
And this is Michael.
And it's me, Eugene.
Okay, and let's dive right into the big question. So a lot of times in tech, you'll hear people talking about failing forward and iterating fast, but I kind of want to touch on the fact that maybe failure is not always a good thing. And in order to learn from it, it requires like special attention and special precautions. So I kind of wanted to talk about how we do that specifically. Like, how can we learn from technical mistakes? How can we make them a good thing instead of a bad thing? I guess that starts off with like, how do you fail forward as opposed to just failing?
Yeah, that's a good nuanced question there as well. And I think to your point, there's a part of planning that goes into that that's pretty interesting, where you, a lot of people think of it as like you fail and then you make up for it or you find what went wrong. I believe you can create a culture of safe experimentation where you plan your tests such that you already kind of know as you're testing that if you were to encounter a failure mode, you can already sort of backtrack where that failure came from, understand it. It's kind of like doing pre-mortems. You can sort of apply some foresight and preemptively choose a test scheme such that it allows you to discriminate failure modes, for example, as opposed to just testing and then being like, oh, what went wrong? You know. So
yeah, no, and I think for some people, especially maybe for some inexperienced startups, they perceive failing forward as like an excuse to just do whatever they want without a lot of deliberation before testing anything, like you're saying, Michael. I think the one most crucial thing you can, as a team, create so that you can fail forward is just a deliberate plan, I think. And I think that's nothing too glamorous or crazy. I think just understanding what you're trying to test and applying a lot of foresight. I know we've talked about that a lot in the past couple episodes about having foresight, anticipating what can go wrong, and having good instincts on what can go wrong, probably will go wrong. So just having really good safety precautions, especially if you're testing something that is dealing with dangerous materials or anything like that.
Yeah, and I will say that you can design your system, especially in prototypes, in such a way that failing forward is very possible. I mean, or is more likely easier to achieve. And one example that I like to bring up is when people are designing printed circuit boards. Oftentimes, people will make the mistake of trying to make their prototype small, which is a great idea for a PCB that you know works. You want to minimize cost and footprint. But when you're just having a prototype, like, it's much more important that you put on test points. You put extra connections for power and ground and any communication lines you have. That way you can eavesdrop on them. Because when something goes wrong, it allows you to figure out where it's happening, what's happening, and it lets you kind of like maybe even like kind of get in there and like tweak things or like rewire things. Like if you forgot to wire something up to power, you can very easily connect it from a breakout that you have. And sure, the board will be bigger, but it'll be a lot easier to troubleshoot and you'll be thanking yourself later. And yeah, speaking of troubleshooting, that's a whole topic in of itself. I mean, what is your go-to when you have a prototype and it fails in some way you weren't expecting?
yeah, I think to some extent to the point you were just making, well, maybe one step before that. Yeah. I think one important thing when you test, and especially if you test and fail, is to not hesitate to go back to first principles. There's a big temptation to understand and patchwork, but it's also an opportunity to go and sometimes revisit whether you are on the right design in the first place. Mm-hmm. So I think that's something that you can still hold true while you're troubleshooting, but sometimes it's easy to lose track of that because you have a lot of sunk cost. But now maybe more so to the point you were making, as you're doing that and you're trying to understand your first order drivers, looking for cascading effects. And that's where instrumentation can be pretty key to understanding that and just thinking ahead once again. But yeah, just looking at how an error propagates for a system, because if you don't have that instrumentation, usually it could be 3, 4, 5 failure modes that happen. And, good luck isolating it unless you have, again, kind of applied that foresight in the design of your test, from the start, and the instrumentation that goes with it. So understanding those cascades is really important.
Yeah, and you mentioned earlier, Michael, about sunk costs, and I think that is definitely something, especially for younger people, is such a true thing to struggle with. If you're trying to, especially when you're prototyping something, maybe you're a college student, or maybe you're a new grad doing something for fun, and you're creating something out of scratch, and then your prototype fails. I think a lot of times we do start with that preconceived notion that what we did end up trying to build that is being tested is the best solution. So we're trying to troubleshoot things with the lens of, I want this to work without taking that step back and be like, hey, is whatever I created, was that even the right step to begin with? And I could speak in maybe one example where, I mean, a past class project, I was creating like this really silly like an Arduino project, Arduino thing with multiple solenoid valves. And I was trying to connect them with a breadboard and stuff. And initially, like, I remember the valves just wouldn't be powered when I was trying to fire circuits. And I think what I was missing at the time was I just didn't add any like solenoid relays and stuff to redistribute the power from the Arduino with a power adapter into the valves. But like at the time, I just was so focused on just trying to get my idea to work, and maybe not being able to let go of that ego of like realizing, hey, maybe I did something wrong beforehand, or just sometimes maybe the whole design could have been replaced with something different that's just way more effective and requires less steps. But the fact that I maybe went out of my way to purchase all these parts already, I wanted this to work, and I would just feel so sad if everything I paid for just doesn't work anymore. So yeah, the whole thing with sunk cost is such a real thing.
Yeah, it's a real thing. Once you go ahead and you bought the material, and you're like, oh man.
For sure. Yeah, and I mean, that's a really difficult situation to be in. Like, what can you do if you go through this testing and you figure out essentially that your first principles are wrong, that like your design needs a major revision, even if, especially if the schedule's tight?
Well, yeah, that's the part of learning, I guess. And definitely once you pass the ego hit, like right after that too, it's, I think especially if you got schedule involved, then it's like an extra dimension added to that. And that's really when you got to prioritize core functionalities. And that is also kind of its own ego hit sometimes, because you may have been working on some parallel, secondary, tertiary features that are cool. You're kind of invested in them emotionally, but ultimately, if you have a schedule to meet, you need to make sure that whatever is mission critical is what you actually get right. And that may mean dropping certainly the tertiary functions and maybe some of the secondary ones. So kind of keeping in mind what those are in the first place sometimes to keep sort of your priority list in order is critical, because when you hit that hard spot, that allows you to act on it a little faster. And yeah, we're just kind of just adding the complexity as you go as well. You can take sort of a more incremental approach in your prototyping as well, or in your development, where you make sure your core functionalities are there so that even if you surprise run out of schedule, you're still on track. And then if you have the luxury of time, you can roll in secondary features as opposed to trying to roll everything out right off the bat.
Yeah. No, actually, that's actually such a good point, where it's like, it doesn't have to be one, you have probably a life cycle for a project, but that doesn't mean that has to be the only life cycle for a single thing. You could keep on iterating and doing multiple things. And you mentioned earlier, Michael, about like maybe you would have to sacrifice some tertiary features that you wanted to put in the initial product. And I think there is even still there is a reality where maybe you have to sacrifice one or two primary objectives on something, especially if you're on such a tight schedule where you realize, hey, something didn't work, but you don't have a lot of time to address everything. Something's got to give, and that's where you have to be able to put that ego aside and be able to apply some sort of triage and be like, what is the most important things? And maybe you do have to sacrifice something that is critical, but for the sake of getting the rest of the product out there, at least, that's just maybe something that you just have to bite that bullet and just roll with the punches. But but it's not like to say you can't go back and add more after the product's out there. So maybe for some people, they could benefit from just applying less pressure on getting the first iteration out there, and not have to put too much pressure on striving for perfection the first time they're trying to do something. Yeah,
those are definitely all good points. And sometimes a product that isn't quite teed up to meet its primary objective, sometimes it can find new life, like in an unexpected way. So it's worth evaluating kind of like what you're making, and if like you can't meet the objectives that you initially set out for, like what's something you can still, especially in a business context, can still make it economically viable, even if it's not as lucrative, assuming that, the schedule is more important than hitting that mark.
Absolutely. Yeah. If you got pragmatic, incremental sort of checkout points too, then it certainly makes your life a lot easier. And yeah, testing as you intend to operate, honestly.
Yeah.
I take incremental progress in the proper environment any day over a full set of features in a simulated environment, or one that's not, flight-like, so to speak, if you're in space.
Yeah, that's important, because when we talk about I've heard that, simulations are always doomed to succeed. So you have to make sure that when you're testing something, you're learning the actual mistakes that are going to occur in the system. Yeah, well, all this talking about making mistakes is a little bit bleak, but how about instead of making our own mistakes, we learn from mistakes other people have made? How do you do that?
That would be nice. That's a good one because it's not that easy. It sounds like it should be, but it really isn't. I don't know. I'm a big fan of the idea of repositories. Also, maybe that's mostly just coming from space. A lot of information is typically siloed. But even in startups, other environments, having a repository of knowledge that everyone can kind of access and chime into is super important. If you think about the idea of hiring people that have experience, it's almost a shame to hire people that have experience if they don't get a chance to contribute to that repository so that others can learn from that.
Yeah, it's absolutely a plus for them too to come to your company if they can learn about other fields and like build their own knowledge.
Exactly. And a lot of times you'll have, someone who might have been on XYZ project and learned something, and then someone who's seen a similar problem from a different context. And now because they have that ability to communicate or see stuff in that same repository, they can build on each other's experience. And that's where you get some really good things that come from that.
Yeah. I guess I wanted to start off by saying we do live in a world where it's so hard for some people to just be vulnerable and share like what mistakes they have made, especially for startups, just in the competitive environment. And I've shared this one report with you guys several times even before recording. Just like I remember last year or so, I was really obsessed with like reading Astrobotics Peregrine 1 report. There was like a mission that wasn't successful, but they were really transparent in sharing like what the lifetime of the project was like up to the launch of the rover and the satellite. And it came down to maybe like a valve or two that malfunctioned, that then inhibited the system out in space to be able to deploy critical systems. But like being able to read like professional, authentic reports like that are like a great place to start.
And then looking at others' postmortems, like you said, Peregrine,
and more importantly, once you find those resources, it's important to be able to extrapolate like the principles that maybe that party overlooked, not just look at the specific issue. Like, maybe this one company forgot to check a valve or something, but that's like really third order, low level issues. But what happened? What were the other dominoes that kind of fell to that point? Was it a schedule oversight? Maybe they didn't hire enough people. I know for Astrobotic, they were relying on some third party vendors rather than going full vertical integration to develop all their systems. Maybe could someone perceive that as a mistake? Should Astrobotic have done something different? I don't know, but like I guess that's really up to the individual who's reviewing the stuff to think about and look at from a bigger picture what could have been done differently so that maybe the end situation could have panned out into something maybe a bit better.
Yeah, absolutely.
Yeah, I think that's a great point. And it's also a bit difficult because postmortems are great, but people are more readily willing to share their successes than they are their failures. Exactly. Especially on LinkedIn. not to harp on LinkedIn. It's not that episode again. But to build on what Michael said about kind of having expertise on the team, I think one thing that's very important to actually utilize that expertise is making your analysis very clear. So a good example of this is the difference between an Excel file and a Python script. If you were to bring like an expert consultant in to look at your project and look at your analysis, on a Excel file, it's a lot easier for them to see like which values are you using, what assumptions are you making, what's your model, your equations. Whereas if it's like a Python script, they have to dig through it, they have to figure out what's going on. So I really think it's important that analysis is transparent, it's readily understandable, and it's aptly communicated to people who are advising you. Because otherwise, they might not catch something that they previously made a mistake on, and now they're trying to, and they have the opportunity, because you're clearly presenting your analysis, to chime in and be like, oh yeah, I've made that mistake before. You shouldn't do that.
Yeah, absolutely.
Yeah.
Big fan of Excel as an analysis communication tool.
Yeah, and that's really one of its strengths. You can just kind of look at it and get like a broad picture of what's going on.
Yeah, true. And it forces you to think about, because there's a lot that you can't do, which it can be a good thing. You have to focus on like the primary drivers. You're not necessarily stuck on the transient responses and stuff like that. And it does nicely allow you to focus on the things that matter in the
even
analysis.
If you are running like a simulation, you should still be very clear about what part of the simulation is actually the human aspect and what assumptions you're making. Because no matter what analysis you're doing, there's some human elements baked into it.
Absolutely, yeah.
Okay, I think that's a good discussion about how we can be learning from technical mistakes, both our own and those of others. So I think it's a good time to move on to our second segment, Thanks Mom, where we get 2 words from ChatGPT and we create business ideas out of them.
We don't make mistakes. What are you talking about?
This idea is going to be perfect.
Well, yeah. So let's figure out what Mom has has in store for us. So here we go. Without further ado,
What do we got?
This will be fun. Prism zipper. Prism
Alright.
zipper.
Prism
Time
zippers.
for a brainstorm.
Prism like the shape, and zipper like what you have on your clothes.
Okay.
All right,
Sounds
that's
good.
gonna get creative.
All right, I guess we cued the time lapse. So that's time, right?
I think so.
Yep.
Alright.
So
So we'll. Should we go?
this was a
around here?
tricky one.
Yeah, pencils down.
Yeah, time's up.
Oh no. Shall we go around?
Yeah, sure.
Yeah.
I will volunteer to go first.
Lead us to victory.
Okay, so my first idea is that of unzipping a prism, or more specifically, unzipping like a optical cable or an Ethernet cable. So it'd be some sort of robot that you have these cables that, you know, they have the like overall sheath, and then you have all these cables inside of it. So it's a robot that can like cut it open, splice it, and then it could either like attach two cables together for like a repair, especially in like remote places. For example, like undersea cables, these probably exist for that purpose, but it could also be used for like a espionage purpose where you're like splicing a cable to put like a receiver in there so you can eavesdrop on the network traffic or like issue commands. So we're trying to think about how you would design a robot that maybe it's airborne, it would definitely be very small, but can like figure out what cable it's looking at, has all the tools to like splice it open and then make these connections to each individual wire.
Yeah. I went in a similar direction of you're not intentionally splicing it, but if it's already being spliced, like an accident or something, or a fiber optic cable got cut and then you like join them to fix them.
Mm-hmm.
But similar direction too. I was thinking zipping, joining together, you know, like intermeshing and stuff. But I think that's pretty topical too. You know, you do have some subsea cutters essentially
For sure.
for your internet cables. So that's
Either cutters or wiretaps. Yeah.
Yeah, when I heard of the word prism zipper, I was trying to think of like stuff with crystals that can fuse things together. Like what a zipper does, it binds two pieces of cloth together normally. First thing that came to my mind was this YouTube short I once saw a while back by Niall Red. He's
Mhm.
a popular chemistry content creator guy. And I remember he was doing some sort of experiment. I was just looking up this earlier, where he creates like these like this tower using baking soda and vinegar. And you would essentially what that creates is what he called like what people call hot ice, which is essentially just like super saturated sodium acetate. But like that was what popped in my mind earlier, and I was thinking maybe Prism Zipper could be the name of some quote unquote crystalline glue, where you can like essentially create some sort of reaction where you have crystals and stuff that can bind things together. So I was even thinking like, you know, if you have food in your freezer or in the ice box, and like maybe there's some liquid or water before you put stuff into the freezer, like maybe you have different like meats and steaks. Like sometimes stuff like two pieces of meat and stuff gets stuck together with ice, and it's really hard to like take them off until you melt the ice or something. So in my head, it's like maybe this could be the name of something where you fuse things together using some additional material between the two. Something like that could maybe be super useful in maybe an extreme cold environment, like maybe an Antarctican base, maybe a base in Antarctica. I would have to dig deeper into the physics to figure out to see if that works. I was also even thinking maybe that kind of glue can be useful. You mentioned that underwater operations. Maybe having something that immediately turns solid underwater can be useful rather than some sort of viscous fluid like glue, because that could then just be like, you know, lost underwater. But that was the one thing I was kind of thinking of just now.
That makes me think of like maybe a optical system where you have like the sun and you have some sort of like metal that melts at a very low temperature, and just using the sun you can like focus light to melt this material to like fuse two things together.
Yeah.
So it's sort of like a bonding agent that, you know, you concentrate solar power on it, you heat it up, and you can fuse two things.
Yeah, kind of like a form of welding, yeah, essentially.
Yeah.
You have explosive welding, and then you have solar concentrator welding, could be the new take.
It could work anywhere, especially like if you're out in a place without electricity.
Yeah.
That was actually my second idea, where you
really?
have like, it's like a magnifying glass on steroids, where you just focus solar light into whatever you need to fuse things together. Because maybe if you have just a tool like that, that would beat having to purchase glue or other things. You just need one tool that, on a sunny day, you
You
need
could
the
probably
light.
get a stronger joint if you're like melting a specific material.
Yeah.
Well, to mention an idea that isn't just psychically stealing one of yours, I'm like, okay, zippers, they're, you can like basically turn them on and off very easily. You can like remove them, or not remove them, but you can open and close them very easily. And so I thought, okay, a prism is, like sparkly and colorful. So what if it's some sort of like dynamic dazzle camouflage? Or maybe it's like a fashion statement where, how clothes will be like very sparkly and reflective, but you can turn that on and off. So either some like material structure, or maybe you run a current through it and it causes molecules to align in such a way that they become very reflective. Okay. So you can change like the surface properties of some material to make it like more prism-like or more dull.
I'm picturing a soldier just getting uncovered and be like, aha, the old razzle dazzle, and just like
becomes extremely sparkly.
They're blinding me. No, but that could be cool. Yeah, definitely could be a fashion statement. And yeah, I think the ability to optically like change your camouflage could be very interesting as well.
It could be like a very adversarial pattern, for example, like image recognition AIs.
That's a good application of it. Yeah. If you have
where all of a sudden it's like, how is that a person? It's like sparkly and has all these strange lines on it that are shifting around. Like,
there's no way someone would wear this.
Yeah, but if you have an autonomous system, it's like, what the heck is that? Like, that's not what a person looks like.
Absolutely. Yeah. That's probably going to become all the more important too with the advent of AI and those kind of use cases of like image recognition and pattern recognition within visible images. Yeah. I was thinking zippers, joining, combining, but also like in sort of a human aspect, and then Prism being multifaceted. So I was thinking of a coaster looking thing, maybe has a little like telescopic element on it that essentially allows you to create a little hologram, like spin, create a little hologram for some more fun video conferencing where you can just have it in your pocket, right? It's your Prism zipper, you just take it and then you can have a chat, just, lay it out on the table and then have someone that's more of a face-to-face kind of conversation rather than needing to go through like a phone interface or a laptop interface, kind of, I feel like it'd be kind of interesting.
Yeah, especially if it's portable, that'd be really useful wherever you go.
Yeah, a little coaster looking thing, and then make for a more interactive experience at least. Too. Yeah.
I'm out of ideas now. Let's do one.
No worries.
This one got me stumped.
One of yours, so it's only fair.
I need to pick your brain next time.
I've only got one small one left, which is just, what has zippers? Tints. So you could make a clear tint that perhaps it's like a meditation tint, and it's full of very relaxing rainbow colors from the prism-like surface of the tint.
Yeah. When you said transparent, I was picturing one where maybe it's like a full moon, you go camping outside. You're still sheltered from the elements, like rain or the wind, but you can see
what's going
everything.
on.
Yeah. It could be kind of interesting. My last one was seeing zippers and going fast and zipping through things. And I was thinking essentially it'd be funny to have a low poly bike that you can just have modular parts. You can maybe combining in different kind of ways. Looks like it's out of Minecraft, still has round wheels, so you can actually use it to zip around. But I figure that could be like an interesting opposite take on sort of like the trend now where things are more minimalistic and streamlined and sort of these futuristic curvy shapes, and just go the other extreme with a very sort of blocky, low poly kind of approach to design.
Yeah, I mean, it's just like the Cybertruck, but now for bikes. You're gonna have like a
exactly
bike, I guess. Yeah,
exactly. Those prismatic shapes essentially, and then zipping around. I was like, okay.
Well, I see what you're coming from.
Yeah, exactly. Yeah.
I was thinking, going back to the tent idea, maybe if the tent itself could be I don't know the right word for this scientifically, but like essentially if you're in the tent, but you could look outside through the tent.
Like a one way.
Yeah. Because I imagine that just might be helpful. Maybe you're in the tent, but you just don't want to be bothered to open the tent to see what's outside. Maybe you're in a forest or something, and maybe it's more dangerous. You don't want to stick your head out, whatever's out there. Maybe there's a pack of wolves or something, and in Big Bear, you're like, maybe it would be useful just to look through the tent and just see what's around you rather than having to poke your head out and expose yourself to whatever is out there. So
what if it's a bear with that t-shirt with the adversarial pattern fighting?
No. Maybe you could combine them where the tent like does some weird like sort of changes like color to like sort of scare off
zebra stripes.
There you go.
Hey, that could work. It works in nature. Works on sharks. So you never know. Does it work on bears? Only one way to find out.
Okay, well, I think those are some pretty good ideas. Well, let us know if you have any good ideas for how you can learn from technical mistakes and turn failure into a stepping stone for further success, as well as if you know a good idea for a prism zipper. And we'll see you next week. Have a good one.
Yeah.
See you on the next one.